Involving radicals. Perhaps you remember this from last year. You can multiply by the, what they call a conjugate pair, and you can simplify that way. All right? Direct substitution here, if I plug in a 4, 4 minus 4 is 0. If I plug in a 4 in the bottom, 2 minus 4 is also 0. Okay, so 0 with 0 is inconclusive. We need to do some more work. So what I do is I multiply by the conjugate of the denominator, whatever one has a radical. And this one, I'm multiplying by square root x squared plus 9 plus 3, yeah? And the bottom too, square root x squared plus 9 minus, plus 3. Okay? What's going to happen is I can multiply these out and the radicals go away. We'll still have this on the bottom and I'll talk about that in a minute. Here, what are we multiplying by? Raise your hand up to yell it out. What are we going to multiply by here? The numerator and the denominator. Norm. 2 plus root y. Okay, now when I multiply this, yeah, it's not, yeah, it's fine. 4 times 2, we're multiplying it out, right? But what I would recommend to you is you don't FOIL this out just yet. But what's happening is I'm multiplying this binomial times this binomial. So we got 4 minus y times 2 plus y, plus root y. Leave it alone for now. If you need to multiply it out later, sure, be my guest. But for now, just leave it for a second. In the bottom, we multiply. 2 times 2 is 4. Then you got positive 2 root y, negative 2 root y. Those would cancel. And then negative root y times root y, which is negative y. Okay, so we're going to end up with 4 minus y. Do we agree? Yeah. You guys with me? Yeah. This is the whole reason we did that. Because look now. And aren't you glad you didn't multiply it? Aren't you glad you didn't multiply it out? Boom, boom. That factor is shared by the numerator and denominator. So this, and by the way, this should have a limit as x goes, or as y goes to 4. Anyway, at this point, we plug in our 4. 2 plus root 4 equals 4. When we do our direct substitution, we no longer need the limit notation. Because at that point, we're directly substituting. So we cancel the common factor. Then we get 2 plus root y. Plug in our 4, and we get 2 plus root 4 is 4. Let's see what happens here. Limit as x goes to 0. By the way, I didn't test this one, but if you test, 0 goes in there. Square root 9 minus 3 is 0. 0 on the bottom, 0 over 0. Okay?
How'd you make it plus?
How or why?
Why?
Why did I make it plus? Because we want it to be the conjugate. So if this is minus 3, we make this plus 3. Because when I FOIL this out,
so
it'll be this.
multiplying those two together?
Exactly.
Oh.
I'm multiplying this times this.
That makes more sense.
And now I get square root x squared plus 9 times square root x squared plus 9. It's going to be x squared plus 9. And then this one's going to be a positive 3 square root. And then this one's going to be a negative. Those will cancel.
Yeah, so n minus 9.
And then negative 3 times 3 minus 9. Again, don't multiply out the bottom. Watch this. X times root x squared plus 9 plus 3. I'm not going to distribute this just yet. If I have to do it later, sure. But right now I'm going to leave it. Because watch what happens. We use my purple because purple is a good canceling color. This 9 is canceling with this minus 9. And notice the x squared and the x. Okay? This is multiplication, so this x can divide out. We can get rid of this x. And then one of these. How's that helpful? Because I'm plugging in a 0. You can't have an x in there. Eliminating an x is going to be very helpful. So let's go to the next line. Limit as x goes to 0. What happened after all our simplification? We get x over, and then we get square root x squared plus 9 plus 3. Plug in a 0. What happens? 0. But this time on the bottom, we get square root of 9 plus 3 is 6. So 0 is 6. That's 0. At that point, we can say with confidence, we definitely have 0 now because the denominator is not equal to 0, it's just the numerator. right? Question. What if you couldn't have? If I multiply this, if I'm doing this correctly, this limit it started off 0 over 0, it should work every time. Yeah, if this started off being 0 over 0, and I multiply by the conjugate pair, then chances are we found the factor that cancels. That's the whole reason we're doing that. Now, if this wasn't 0 over 0, you might not be able to get it to work, but that also means you probably have a vertical asymptote, and it's going to positive or negative infinity. What questions do you have?
The answer is 0.
This answer is 0, yep.